Hi everyone, I just wanted to make another quick video, kind of just summing up the different forecasting lessons that I have shown you over the last couple of weeks. And from this point forward, we're going to continue to be building upon different skills. And this week I introduced you to pivotal weather. So if you haven't watched the how to navigate pivotal weather video, please do so before watching this video, because if you don't, this video will not make any sense to you. So last week's forecasting lesson was how to use the NWS grids, which after reading most of your discussion posts, it seems as though most of you really liked the layout of the NWS grids more so than using MOS, which is totally understandable because this is very much visually appealing where MOS is not. However, what I didn't tell you is that the NWS grids is actually the forecast put it into grid form from the National Weather Service. So basically, this is the National Weather Service's forecast in a gridded view, whereas MOS is the raw model data from the NAM and the GFS. And after using pivotal weather, here you see that there's a bunch of different models that you can use. So we have the ECMWF, which is the European model, which is fairly hard to actually kind of find for free just because it's from the European Center for Weather Forecasting, and therefore, since we live in America, you have to pay for that data. Now, the European model has been notorious for being more accurate in terms of weather prediction than the American GFS model. And that's simply because the European Center for Weather Forecasting just has built a better model. They put a little bit more money into it. They have more servers so they can generate more power and so on and so forth. And the GFS is getting there. And not to say that the GFS is a bad model and the European is a good model. Oftentimes the GFS will be a little late to the party, meaning to say that sometimes it'll start to copy the European model just a couple days later. So let's say like there's an event like a big snowstorm coming. Sometimes the European model will hint at it a little bit quicker than the GFS. Sometimes the GFS will hint at something like that quicker than the European. They both have their days. If they were two students in school, the European would kind of have a GPA of about 92, and the GFS would have a GPA of about 91. So they're very similar. They're just built a little bit differently, and that's kind of just the backstory to that. And then also the United Kingdom, they have their own model. The Canadians, they have their own model. There's some different ensemble members. So, you know, the list goes on and on. Right now, I kind of just want you just to worry about the GFS and the NAM, and you can play around with some of the high-res guidance here as well. All these under the convective parameter, these are basically all the NAM's cousins. So here's the original NAM model that I talked about earlier on in the semester, and these are all the first cousins. It's basically just the way that they're built. They're built a little bit differently. They don't go out as far, meaning to say the amount of data that they use is extremely large because they're built for more high resolution fine tuning. So basically, if you wanted to fine tune a forecast within the next couple of hours or even the next day or so, any one of the high-res models would be a little bit more fitting. And especially if you're looking in terms of like severe thunderstorms, the last three would be your best bet. But I definitely want you to play around with the NAM 3 kilometer. It's a little bit more higher resolution than the actual NAM. So the NAM 3 kilometer, it's one of my preferred models. The HRRR, I call it the HRRR model. The HRRR is actually really good too, especially if you're trying to figure out forecasts within the next couple of hours. I don't think you'll play around with that one too much, but I want you to click around just to see what you like and what you don't like. So in essence, this is a great way, the National Weather Service grids, this is a great way to figure out if your thought process for whatever location that you're forecasting for, this is a great place to see if you are actually on the right idea. You don't have to, have the same numbers or have the same timing as the Weather Service. That's totally fine. But if you're like, I'm not really sure if I'm doing this correctly, you can always hop over to the National Weather Service grids and you can kind of see if your forecast or what your thought process was basically comes out to be the same. So you can basically kind of check your work, if you will. So I really still want you to use MOS. Please keep practicing with it. I know it's a little bit of a pain at first, but it really does become second nature. I promise you, I was in the same boat. I know it's confusing. I remember seeing all these numbers and rows, and I thought to myself, what is this? I, was very slow on learning Zulu time. If I can do it, you all can do it. I promise you, it's really not that bad. So MOS is great when you're looking for the fine tuner things in the forecast, but pivotal weather is also really useful as well, especially when it comes to looking at something, on a map. So one of the great things about using pivotal weather, you can, change between the NAM and the GFS. And I want you to compare these two outputs, because just because I use one model doesn't mean it's going to be correct. If I use two models, they don't necessarily mean they're going to be correct. They're just two different opinions, and that's the primary job of a forecaster. And that's why forecasting the weather really isn't that straightforward, just because you have all these different weather models. They're built kind of sort of the same, but they do have their differences. And because of that, they pick up on little differences within the atmosphere. And we don't know if those differences are going to be what's actually going to happen. So this is why it's important to take an average, which is what many of you are doing, and that I'm very happy to see. So here, I'm going to just make a forecast for Washington, D.C., just because we have a little bit of rain coming up later on in the week, and I wanted to focus on that. So what I did here is I made a little graph. Some of you use this method, and I think it's worked out really nice for you. So I have temperature for the high and the low, the wind speed and direction, cloud cover, precip, if there's going to be any timing, and amount. Okay, so I know that there's going to be some rain in the forecast. That's why I'm kind of making this video. So right now I'm just on the basic NAM. And what I did is that let's just do 4 temperatures here. And actually, let's kill 2 birds with 1 stone. And let's do 2 meter AGL above ground level temperature and wind barbs. Let's rock with that for a second. And what I'm going to do is I'm just going to move my slider. I'm going to make this forecast for Tuesday and Wednesday. So I'm going to move my mouse over. I'm just really concerned for about Tuesday and Wednesday. So here's Tuesday, right? Here's Tuesday, 12 Zulu. That's 8 o'clock in the morning. So this should be when the low of the day is, okay? Now here's the low of the day in terms of temperature. So it's right around 69 degrees. And if I fast forward that a little bit to 18Z, this is 2 o'clock. This is when the high of the day should be. You see that it's about 72 degrees. So you notice that the temperature really hasn't jumped up as much over the last couple days. So that's just what the NAM says, okay? I can do the same thing with the GFS. I can change these parameters a little bit. So let's click on GFS, and let's see if we can get the same idea here. So here's Thursday. Sorry, not Thursday. We want Tuesday. So here's Tuesday, right? And we go over to DC. We have a low of about 71. And let's see, Tuesday, 18Z. There we go. And we notice that we have a high of about 78. So the GFS is a little bit warmer. Let's check MOS, because MOS is a good idea. So let's see. I want it for, what are my dates again? Tuesday and Wednesday. So the 29th. So according to the NAM MOS, okay, on the 29th, the low of the day is 65 and the high of the day is 73. And according to the GFS, the low is about 67 and the high is about 71. Now, you might be thinking, well, it's really useful just to go on pivotal weather and just to move my mouse over here and, figure out what the high and low temperature is. And that's absolutely correct. But what MOS is really good at is MOS basically learns from its mistakes. It kind of figures out the trend of the forecast. Every model run is taken into consideration, and it basically gives you a trend just in number form. You don't necessarily see the trend, but just know how MOS is built. So MOS in general, whether it's the GFS MOS or the NAM MOS, is kind of leaning a little bit more towards the actual NAM solution on pivotal weather. So we notice that if we move here, the low of the day was right around 69 degrees and the high of the day was right around 72, 73 degrees. And you notice that the NAM MOS, right, had a low of about 65, high of about 73. And the GFS MOS had a low of about 67 and a high of 71. So now you can see how I'm pulling all these numbers into my head. So when I actually make a forecast for Tuesday, given everything that's been showing up and knowing that based off of my wind direction, you see it's kind of hard to see here, but all these wind barbs, they're pointing down or they're pointing towards the south. That means the wind's coming from a southerly direction. So with warm air being moved from the south, because near the equator, we know that we have warmer air. So if my warmer air is being moved north, I know that my low temperature might not be as low as 65, but I think 67 is a good number based off what I've seen and what Moss was showing. So I think 67 is a good number. Again, if it's 65, the difference between 65 and 67 is really not that big of a deal. So let's say my high is going to be about 73, and then my low is going to be 67. Okay, and that will be my high and low for Tuesday. I know that my wind speed, right? If I go back to pivotal weather, okay, my wind speed's out of the south here throughout much of the day on Tuesday. So I'm going to start my forecast from 6C here. So that would be 2 a.m. on Tuesday. So I'm going to watch my wind barbs here. And so see how my wind barbs still kind of remain out of the south throughout much of the day on Tuesday. And then what happens, right? You see that my wind barbs, they change. Actually, what I'll do is I'll make this a little bit, we'll do a white background. And that's another tab that you can use, mean sea level pressure and 10-meter winds above ground level. And you can just move your mouse over and it'll tell you what the wind speed is, which is really nice. And the darker shader colors are higher wind speeds, but you can see how the wind barbs are still the same. So throughout the day on Tuesday, let's go to Tuesday here. So this is the NAM. Throughout the day on Tuesday, you see that my winds are basically out of the south. And then what happens throughout the rest of the day, you see here that they kind of come out of a northwesterly direction, all right? And here's an area of low pressure. So basically, this just means that there's a cold front coming by. We haven't talked about fronts yet, but we will. But here's a perfect example of one. So whenever some kind of frontal boundary moves through whatever region you're forecasting for, you know that there's going to be some type of weather, whether it's just plain old cloud cover or if it's precipitation. And this is something that we'll learn, especially within the next 2 weeks, this week included. So here you can see my wind shift, right? So when I do my wind speed direction, I can use Moss. I can take that into consideration. See, all my winds are coming out of the south. So here's 170 degrees, 180, 170, 160, right? And then they start to turn, right at 21 Zulu, okay? So that would be 5 o'clock in the evening, 240, and then 10 degrees, and then 350. So basically it comes out of a northwesterly direction, okay, after the front moves by, all right? So that's one way to determine wind speed and direction. So what I'll do here is we're going to go south to northwest, and we'll just do a wind speed of 5 to 10 miles per hour, okay? You could even go lower. I'm just doing a generic 5 to 10 miles per hour. Here's something that you'll really like about pivotal weather. You have a cloud cover tab here. So click on cloud cover, right? And if you move your mouse over, right, you can see the percentage of cloud cover. So 100% would be totally overcast, and then 0 would be clear skies. And then in between, you could say, scattered clouds, few clouds, so on and so forth. But you see here, throughout the day on Tuesday, you see that, Washington, D.C., which is this little box right here, 81% cloud. So it's basically mostly cloudy or overcast throughout the entire day on Tuesday. And especially as we go into Tuesday night, right? And that's important. As we go into Tuesday night, you see that it's still pretty cloudy. So if I go back to temperatures, I know that my temperatures really aren't going to vary that much because I have all this cloud cover, right? And that's important because we know that clouds keep the earth warm at night. They act as a blanket. So here, right, my high of the day was, I said, it was going to be in like the, mid 70s, so around 73. And then as I go through the evening, right, you can see that cold front, kind of cools things off a little bit. So this is a little, different caveat here. So, even though there's going to be clouds, I'm going to be bringing cooler air down from the north. So I'm changing air masses. Again, we haven't really talked about all this, but this is kind of like a little crash course. And so whenever a cold front comes by, that means I'm just bringing in a cooler air mass. So that means during the day on Wednesday, we're actually going to be a lot cooler. And actually, according to the NAM, this is actually really interesting. According to the NAM, it's going to be much cooler on Wednesday. We have a high of 60 in DC. And so that's a 13-degree temperature drop, between 2 days. And I bet you if you kept going here, the NAM, this is already at 84 hours out, so the NAM doesn't go any further out in time. But you can kind of get the rough idea. We can play the same game with the GFS, okay? If you really wanted to, we could play the same game with the GFS. And we just move up in time here. And we see that cold front comes through. And we can see Wednesday, according to the GFS, the high is only about 65. And then, the low on Thursday will be right around 58, okay? Again, that's out of my forecasting realm, but you basically get the same idea. Now, how do you figure out how much precipitation there's going to be? Well, on Moss, it was a little bit difficult. So here, the P group means probability of precipitation in 6-hour intervals, whereas P12 was the probability of precipitation in 12-hour intervals. That's why you don't see any data here. These are blank where these actually have numbers. So again, these are all percentages. So here for Wednesday, the 29th, you can see that the probability of precipitation increases, especially as we go throughout the day. It has its highest number right around 18Z, which is around 2 o'clock. So if I was consulting for somebody and, let's say that they had an outdoor project that they were doing, and they asked, is it going to rain in Washington, D.C. today? I would say we have a chance for showers later on this afternoon, but it looks like, according to the probability of precipitation, it looks like the morning hours are pretty dry. So that person would say, awesome, cool, thanks, and that would be the end of it, okay? And that's essentially what a part of my job is to consult for different people who need to make decisions based off of weather, which is pretty cool, but it can also come with its headaches. But that's how you use the probability of precipitation row in Moss. So Q06 and Q12 means how much actual measurable precipitation has fallen in 6-hour intervals or 12-hour intervals. And there's a chart that goes with this, which is what I talked about a couple of weeks ago. But here you can see that I have a 3 category, which I believe is a quarter to a half an inch of rain that has fallen by 2 p.m. here, okay? But the probability of precipitation has increased from 15 to 58 between 8 a.m. and 2 p.m. So I don't think this number necessarily is quite accurate, okay? So if we go down to the GFS, we can kind of see the same idea. Here's the probability of precipitation in 6-hour intervals. I like that a little bit better just because it's a little bit more fine-tuned. So here you can see that by 8 p.m., the probability of precipitation has increased a little bit, whereas by 2 p.m., it's only about 39%. So as you can see, the GFS is thinking, you know what, I think the best chance of rain is going to happen late afternoon, early evening, whereas the NAM Moss thinks that the best chance of precipitation is going to happen right around mid-afternoon and then continue to increase overnight, all right? So that's just what their 2 opinions are. Then what you can do is you can go here, right, and you can go to Precip Type and Rate, and you can click on that, and basically what it will do is it will show you some, mean sea level pressure lines and some other lines, and we'll talk about that later on in other lessons. But for right now, all the greens would indicate, different blotches of precipitation. So let's go all the way to Tuesday at 6C. And here you can see there's a couple of showers around, okay, but it's not necessarily raining over DC. But this doesn't necessarily mean that it won't rain in DC, okay? But there's just some patchy showers around, okay? Same thing as we go to by 8 o'clock in the morning, you don't necessarily see a lot of, green blotches around DC. They're near DC, but they're not necessarily around DC, okay? Now we go to 18Z. Okay, now 18Z, look, now there's some blotches over and near the DC area. Okay, so that kind of goes in line with the NAM Moss. All right, whereas the GFS Moss thought that this would linger a little bit later. So the actual GFS model is actually more in line with the NAM Moss. Okay, you see here, probability of precipitation was 58%. And the probability of precipitation here was 39%. So it looks like it's a little bit more in line with the NAM Moss, okay, which is the GFS model, all right? So there's different ways that you can base your timing off of that, okay? So if I'm, looking for precipitation, and if there's precipitation, I know my cloud cover is going to be, overcast. So that's a no-brainer. Precip. Yes, I do expect precip. Now, what's the timing? When do you expect showers to occur and when don't you? In the real world, this is a little bit of a catch-22. I would just say that there is going to be showers around mainly afternoon time. But if you really want to be a hero and you really want to test out your skills, which I encourage you to do, the timing here, I would say best chance for showers would be between 12 and 2 p.m. for a start time. Okay. Now for an amount, what's great about this is that you have some options here. You can go under the quantitative precipitation, meaning how much precipitation is actually measured. You can go under that tab and you can look at 6-hour intervals, 12-hour intervals, 24-hour intervals, or total precipitation throughout the entire forecast period. If I click on that and if I, move the model all the way to 372 hours out, which brings us to Tuesday, October 13th, you can see that in those 2 weeks, the DC area, according to this model is, it accumulates 2 inches of rain in the next 2 weeks. This almost never plays out, but it's actually kind of fun just to look. It's what we call science fiction. But here, if I'm going throughout the day on Tuesday, if I want to use the total the total accumulated QPF, here what you would do is you see that it's already rained, right? DC is picking up about, a quarter to 3/10 of an inch according to the GFS model. All right. But I want to go all the way back to Tuesday. So sorry, I was on the wrong day. That's why it's important to figure out your days and times. So Tuesday, 6C, that's 2 a.m. You can see that, we've, barely gotten any rain, 3/100 of an inch. Okay. So remember, my forecast is from Tuesday at midnight through Wednesday at midnight. Okay. That's a full day. So in my mind, I'm going to pretend that this is all blank, right? There's no rain that's fallen because I'm starting fresh. So if I move through time, so here's Wednesday at 6Z. Okay, so that's Wednesday at 2 a.m. It looks like I've picked up about, almost 3/10 of an inch. All right. So whenever you're forecasting precip types, I don't know if it's going to be 3/10 of an inch on the dot. I don't know if it's going to be, 0.28 inches on the dot. I don't know that. Okay. And it doesn't necessarily do me any good to be that precise. And no meteorologist can be that precise. No weather model is going to be that accurate. It's just not how they're built. So if I really wanted to, I can look at what the GFS did for precipitation. I can look at the NAM. Let's see what the NAM does. We'll play the same card here. So let's see. Here's 6C. All right. And basically, I don't have any precipitation that's fallen. So I'm going to go move this through time. And here is 6C, right? So now you see that, oh, look at that. The NAM says 2.2, right? Well, that's a lot more precip than what the GFS was putting out. Okay, so 2 inches compared to a little over 1/4 of an inch. That's 2 totally different QPF amounts. So which model's right? Which model would you choose? Which one do you think is more accurate? So MOS can kind of be the deciding factor here. So the NAM MOS doesn't necessarily go out that far, but the GFS MOS also still doesn't go out that far. So you really can't use MOS. So what do? Well, choose another model. So let's say, okay, that was the NAM. Let's do the European high res and let's do the same idea. Okay. So here, right? Let's pretend this is blank. Okay. So let's take off, 5/100 of an inch in our minds and Wednesday through 60. So this is about, 0.37. So the Euro is a little bit more in line with the GFS and the NAM is pretty much the outlier. Okay. Well, what about the high resolution NAM? Does that paint any better of a picture? So let's see. We're going to go all the way out and I think we're just going to, we'll just make it. Okay. So the high res NAM, right, it's not showing any precipitation now, so I don't need to keep in mind, any kind of difference or any kind of, offset or anything like that. So here for DC, we have roughly about a half, we'll just call it a 1/2 inch and we'll call it a day. So the high resolution NAM is more in line with the GFS and the European model, okay? So I feel a little bit more confident for right now, especially since I'm making this video on a Sunday. So I still have a couple days to go, but I feel a little bit more confident on putting a range on here. So for precip timing, I'm going to, say, 12 to 2 p.m. into Wednesday. And what I'm going to do here for the amount is I'm just going to give a range. So for right now, I'm going to be conservative. I'm going to do 1/4 of an inch to a 1/2 an inch, okay, of precipitation. And that's how I would set up my forecast. And this is what I want you to start to look into. I want you to start gaining a consensus, gaining an opinion, okay? And this is how professional meteorologists do it. We just don't look at one weather model and run with the idea. We take into account multiple different weather models. And so for right now, that's what I want you to do. I want you to play around with the tabs on Pivotal Weather. You can't do anything to break it. Don't be intimidated by it. Play with different things. If you have any questions, ask me. I'd be more than happy to show you what different things mean. Other than, the ads always popping up, that can be a little bit annoying. But try it out, play around with it. And this will be a big step in your journey on learning how to forecast.